Okay, perfect. So, welcome to Wallet Devs number 4. We have a few things on the agenda today. The first, official item is the URI URL working group updates. So, if anybody here wants to talk about what they've been working on or what the URI URL working group is even doing, go for it. And if not,
I was just going to say, sorry, was that like the demo?
Sorry, I have to server mute you. Your mic is horribly, horribly broken.
Concur with Sam. James, your mic is incredibly broken right now. If you go into Discord settings under voice and video, you can do some local tests and see if you can figure it out.
I think you might sound okay now.
Yeah.
Okay.
No, that was just on my side. Sorry. Sorry. So was this section just for general demos or specific to, you were saying UI UX something?
Oh, this is for, so there's a separate working group that's being hosted by the cat herders on URIs and URLs. So we have a couple different proposals that are being discussed there. So if you've ever seen like the Ethereum pay dash URLs or anything along those lines, that's kind of coming out of that working group. So the most basic one is just simply like an ETH : then a prefix and then a payload, and that's kind of like the family of URI URLs. And this is something that we're thinking of bringing into the All Wallet Devs call instead of keeping it separately. So I mean, obviously, wallets are going to have. Sorry, this isn't really my working group. I'm just going to try and give a summary on it. So, we want to bring it into the All Wallet Devs call just to because wallets are the ones that are probably going to be implementing a lot of these URL handlers, and there are quite a few different proposals on what types of URLs to support. So one of them is like transaction receipts. One of them is just simply sending money. So the EIPs are in the agenda if you guys want to take a look at them. And I think Key here is also working on 4804. So if you want to give a summary on that particular scheme, please do.
Sure, absolutely. So I think a lot of people may not have some background. I think some of them already have, but maybe a lot of them you may not have the background. So probably I can have a quick go through what I'm going. Let me see. What the EIP 4804 is going to do. So I need to wait. I'm trying to share my screen, but looks like there's a security privacy I have to enable. So I'm sorry, I have to restart Discord to enable. So we'll be back 1 minute.
Sure, we can probably move this to. Actually, James, is your screen sharing working? We should probably check that too.
Sorry, was that in my screen sharing working?
Yeah, because you wanted to give a demo, right?
Oh yeah. Well, I'm actually handing over to Blake, who's prepared it. So we've got from our team, we've got John, Jake, and Blake from the BLS Wallet team.
I just want to make sure your screen sharing is working before we get to that section.
Yeah. Well,
yeah, okay.
I'm not sharing my screen. So yeah, Blake, if you want to do a quick test with yours, and then we can
I'll check mine now.
Guide it from there.
Okay, I'm back. So let me share my screen. Can you see? So I have present this to the previous URI working group, and so this is basically how the motivation. Basically, we see there's a great trend that a lot of NFTs they are uploading their web content on top of blockchain. For example, one example we saw is Cyberbroker, which they said they have uploaded all the media data, the SVG layers on the blockchain, so that the narrative is that they will never lose the media files. So because it's stored on top of blockchain. So I take a look at their contract and see how they are able to achieve that. And so this is the example of their contract. And there's a token URI. So see how they are able to retrieve those content from, for example, Ethereum, as they said. and which from their token URI, I see the image field, which is still using IPFS, which we know that IPFS may discard the data if nobody hosts it. So, and then I further take a look at how they do it, and then they actually have metadata contract, which basically stores all the layers they have stored, and then they can, for example, random any token, for example, given ID, and starting from their offset that is from 0, and then they will random all the layers one by one, and then so given the next offset, so I can curve the next part, and then so this just continues. Then I can retrieve all the SVG components that they upload on Hot blockchain. So I think this is really interesting application when we realize there's such kind of like using Ethereum mainnet as their storage layer to upload some they found valuable objects. Another example I found is called Adblocker. I recently found they have also said that they are basically a FT that upload some code that is able to randomly generate some pictures according to their code. So this is an example. So they create a lot of basically different NFT images by just using different random seed but the same code. So they claim that they're able to basically replay all these pictures on top of Ethereum. However, actually, we also double check their contract, and so and they are still also using their centralized servers, which is Autoblock / some token ID, something to random those objects, even though I can find their JavaScript on the Ethereum mainnet. So the core motivation of ERC 4004 is basically to be able to directly query a smart contract and is able to basically download this smart contract data and be able to random those data directly on top of the browser or any other tools. So here is let me just quickly go to this one. So this is kind of like a similar HTTP schema, but it's using currently Web3, which we register at INA, and then it will tell us which contract you want to call. It can be ENS or the 20 bytes contract hex, and then corresponding chain ID, and then the method ID and corresponding parameters. And there's a way how to process these parameters in different types defined in the standard. So for the setup broker perspective, we basically create a contract that is a scam that is at this location. And this contract actually is very straightforward. It just tells which token ID that want to render and just repeatedly call the setup broker's contract and then to obtain corresponding the offset and then call next time until the offset becomes 0 and concatenate all the bytes so that we can obtain the final SVG FT files by this method. And then with the standard defined, so we are able to render it. So this is the Web3 scheme, which we have this ENS register as this address, and then we call this method and provide the parameter which 5 is the token number. So I have a browser. Here is Firefox that enable this feature. So it's through a gateway that implemented by us. So it just provide the rest of the field that it will automatically look up the corresponding address and call the contract with the corresponding method. And now we are able to directly random this contract using the URL. So this is the main motivation of what the EIP 4804 is doing. So right now, EIP 4804 is in the review stage, and Sam also gave a lot of suggestions, comments on how to be able to be, for example, work with existing standard, and also some, for example, how we are able to parse those query parts, query and also argument parts, so that we are avoid confusion. At the same time, we be as close as HTTP. So right now we are looking for one or more reviewers to help to review the standard so that it can be able to be more production ready. And there are also a couple of community members actually is asking me whether the stability of this standard so that they're able to incorporate those links, for example, directly into their token UI, so that they don't need to worry about to using IPFS or other third-party centralized servers to store the token UI, so that you can retrieve all the data permanent on top of Ethereum blockchain. So this is the motivation status, and I'm happy to answer any questions.
So what are you looking for from wallet developers? Are you looking for a review?
Yes, and definitely if there's for example, wallet developers or some maybe other, for example, supports that is able to random to apply this standard, then is far more welcome. Yeah.
So is this something you'd like to see implemented in Wallet? So like if you type a Web3 URL in the browser, the wallet would render the content for you, or?
Yeah, that's one direction that we're
Okay.
thinking. Yeah. Any other questions?
Cool. So thanks a lot for giving us an update on that, and yeah, definitely looking forward to seeing where it goes. Now I think BLS Wallet wanted to demo some new features, and I think that'd be kind of cool. So I'll turn it over to them.
Yeah, thanks. Yeah, so I was just saying, I've got the team here, and Blake and John have recently started with us. But yeah, the goal of BLS Wallet is to provide a module that other wallets can integrate to basically get transactions on layer 2 cheaper than they already are by doing signature compression, and yeah, which reduces the size of the rollup. We've got a client module that we've integrated into a prototype wallet, which is just called Quill, and that's what Blake will be demonstrating. So he'll be using Quill and just showing some of the features that the smart contracts provide. So as well as the low costs, we've got multi-action user operations. So we're using the same terminology as 4337, but we're not yet compliant with 4337 as it's still moving around. And yeah, so Blake, if you're ready, I can hand it over to you.
Yeah, thanks, James. I'll go ahead and share my screen. Great. Excuse me. And I actually went ahead and created a video of this, so I didn't have to worry about a live demo. So I will go ahead and start the video, and if anybody has any issues hearing, let me know, and I'll try to get that fixed.
I hear nothing.
Sam?
Yeah, I'm not hearing anything yet.
Can't hear that. Well, dang. I actually don't know how to get a video too, or how to get Discord to pick up the sound of the video.
Oh, once you were screen sharing, it was an option.
Let me try again.
I guess. I mean, you already screen.
Yeah, you might have to end it and reopen it with different options.
I mean, it's definitely possible. Like, I can tell you that.
yeah, just some filler in the meantime. Yeah, we've been reaching out to a few wallets over time. We've just had the contracts audited. We've got some fixes to put in, and then yeah, once we're in mainnet, we will just sort of go back, hit up the wallets that we're interested and reach out to some more layer twos as well, because we have to deploy the contracts on. Well, we're going to be deploying them to Optimism and Arbitrum first, and then yeah, other layer twos that have approached us as well for their own chains.
So this works by having like a smart contract wallet kind of thing that holds people's funds and then use BLS signatures to compress them together, or?
Yeah, so basically you've got a verification contract that is basically a wallet factory, and that will create these wallets. Those wallets trust the gateway, which is why we had that code audited, to call generically call functions through the wallet, and so that gateway will check a bundle of user operations. Each user operation is signed by a BLS key held in the client wallet, and the aggregator, which eventually will be integrated into L2s, aggregates the signatures together, and then that bundle is sent to. Oh, you're going to get the feedback. Yeah, so that bundle is sent to the verification gateway contract, which then performs each user operation via each wallet. One key feature as well, which I don't think is in the demo, is that ADAPT can sponsor transactions. So it's basically gasless transactions by actually coming from the wallet address as well, which I think if I'm not mistaken, the GSN way of doing it, I think is via signed messages, and so the address isn't necessarily the wallet for how it currently works, but maybe it's different for 4337. But if Blake, if you're ready, did you want to try again?
Yeah, I think so. I can try one more time just without my headphones on and the sound coming through my laptop. Turns out I have to install additional software to be able to record the audio. So yeah, hopefully this works. And if not, I might need to try to install that software real quick.
A quick demo of the browser extension that we were working on. Hey everyone, my name is Blake. I'm with the BLS Wallet team of the
Don't forget to start your stream.
Group within.
Yeah, I can't see the screen.
Sorry, I'm a mess.
The audio sounded great though.
Nice. All right, hopefully it works this time.
Hey everyone, my name is Blake. I'm with the BLS Wallet team of the Privacy and Scaling Explorations group within the Ethereum Foundation. I'm here to give a quick demo of the browser extension that we were working on that we call Quill. I'll go ahead and dive right in. I already have loaded up the onboarding screen for the extension wallet, and I'm going to go ahead and complete creating my account. So first up, I need to set a password. Next up, we have the ability to set a nickname. So I'm just going to call this Blake's Wallet. And then finally, you have the ability to view your secret phrase, review it, and then confirm it. It is worth noting that this is an extension that is really just meant for demonstration purposes and not meant to be used with mainnet, which is why we have made it easy for everyone and just displayed the words that you need to input. I'll go ahead and confirm the secret phrase. And as you can see, this brings me to a page here with a smart contract wallet that was generated. I have the ability to add multiple smart contract wallets within the Quill extension. And then on the right side of the screen, we have a few tabs that are related to the selected wallet. Right now, I just have this transactions tab selected, which will eventually show the list of transactions that have been executed. The first thing I want to demonstrate while within the Quill extension is just sending Ether from one wallet to another. So I'm going to do that and send some Ether from wallet 0 to wallet 1. But I need to fund it first. So I'm going to go over to MetaMask and send some Ether to wallet 0. Send 100. Confirm that. Great. Nice. So you can see wallet 0 has updated with 100 Ether, and I'm going to go through the process of sending that to wallet 1. So I'll go ahead and click send, select Ether as the asset and wallet 1, and I will send 10 Ether. This brings up a transaction request modal that I can go ahead and confirm the transaction. And right here, we're just displaying the status of the transaction. We're waiting confirmation. And it should update. Nice. Now you can see it's confirmed. Wallet 0 has 90 Ether in it, and wallet 1 has 10 Ether. So that's a little bit of the functionality within the Quill extension. Next up, I do want to demonstrate a simple application that integrates the Quill wallet. So I'll take us over to this other tab where we have this demo application that interacts with an ERC20 contract. On the left here, we have a component that is linked up to your wallet. Basically, you can mint 10 tokens and approve them. And then on the right, we have a component that is linked up to a spender contract that has the ability to call transfer from and transfer the tokens from your wallet over to the spender smart contract wallet. So yeah, to demonstrate it, I'll go ahead and connect. And as you can see, here is the address that I generated in the Quill extension and the remaining 90 ETH that I have in that wallet. I'm going to go ahead and mint 10 tokens. Take a few seconds. Once that's done, I will approve it. Nice. And last up, I will pull it using the spender contract. Confirm that. Great. Finally, you can see that it has updated the number of tokens in the spender component. Finally, I wanted to demonstrate this bundle up button at the bottom. This is what we're most proud of because most wallets have the functionality to do what I just demonstrated, how mint, approve, and pull tokens. But what's unique about our wallet is that we have the ability to bundle up a group of transactions and send them as one request. So by clicking this button, it'll first do this mint, then approve, then pull all as one transaction. So do this. What's different here is that you can see instead of just having one transaction request, we actually have 3. We have the mint, an approve, and another approve. So I'll go ahead and confirm all of those. And wait for that to complete. Great. You can see that it did all 3 of those as one and incremented the spender from 90 to 100. And we go back to the Quill extension. We can see all the transactions now showing up related to wallet 0. And we have this nice new modal that was implemented that we can click here and see the actual actions that were included in each of the transactions. So you can see the mint, approve, and the contract interaction here. Close that. And the last thing that I wanted to show everybody is the actual code that we use to group those transactions together. This right here is the bundle up function that gets called when you click the button at the bottom of the screen. Pretty straightforward. You can see the 3 different transactions, the mint, approve, and pull transaction here. They're all just using the ERC20 object to connect the signer and then populate the transaction. But instead of doing each of those individually, we are actually sending them using window.ethereum.request and the ETH send transaction method. And then we pass all 3 of the transactions in an array. as part of the params key. It is important to note that this isn't the typical spec for ETH send transaction. Excuse me. Our custom RPC handler actually intercepts the ETH send transaction function and overwrites it with a function that understands the multiple transactions that are passed in this params key of the object that is sent. And then, yeah, last up, we're just waiting on the get transaction receipt to show the updated information to the user. But great, yeah, I think this is all I wanted to show for today. And if you have any questions, please don't hesitate to reach out. Thank you, everyone.
Nice. Yeah, that is it.
Why did you go with ETH send transaction instead of creating a new method like ETH send transactions plural?
Yeah, that's a good question. I'm actually relatively new to the team. I'm not sure if anyone else on the call would be able to jump in for that one.
Yeah, Jake, were you talking with Kortuk about that? I think you might request that section.
Considered just like a separate RPC. I think I don't actually remember the exact on why, but since that is an array, and normally the send transaction uses the first argument inside of that, logical extension to add additional transactions. Certainly could use a custom method new to do that. Really, with the way the wall is working now, it should work like just a general normal transaction, or if you wanted to pass multiple transactions. Is that generally more like a custom method from the RPC like that?
I think I got your question. You're cutting in and out a lot. So when you say you send it as an array, you're saying that each of those transactions is a different parameter in the JSON RPC request, like in the params array, each one separately. It's not an array inside of an array.
Correct. Just going to be, I think the normal spec, and sorry if I'm cutting, is basically just remember through the spec for that. Yeah, I think it's normally one item array, and that's the normal like send transaction format for that window of three. But we basically make it so we actually look at on that first parameter. And we'll also include those if they're valid related transactions.
I see. So a separate question then. I think that's probably fine. I'm a little bit concerned just so depending on whoever's on the other end or implementing the other end of that, when you deserialize the transaction, deserialization becomes much more complicated if you have to deserialize a union versus deserializing just a single known shape. This isn't insurmountable, and I think a lot of things already have mechanisms for dealing with this, but it does add complexity. So something to keep in mind. Second question, though, is JSON RPC, I believe the Ethereum JSON RPC supports batching at the JSON RPC level layer. And so I'm wondering why you chose to go this route instead of just doing a JSON RPC batch.
Yeah, the difference there is because we are aggregating the signatures, like we need to get all the transactions as one bundle. Yeah, and so that's a different, that's sort of why we're doing it that way.
Yeah, you need to get them all in one place rather than three places. Makes sense. Okay.
Yeah, it's one logical request as opposed to three logical requests in one HTTP request.
Yep.
I gotta say, that was a really slick-looking demo, by the way.
James?
Yeah, no, thanks, Blake.
James, if I understand correctly, actually the demo doesn't show the real flow. The real flow is how to get multiple transactions probably sent by different users into a single bundle, and then it's the bundler to bundle them, not the client application in the UI. There are other ways for client application to send multiple a batch of requests.
Yeah, no, I think on the example DApp there, the term bundle up maybe isn't ideal. So bundles are, yeah, definitely multiple wallets signing user operations and sending it to an aggregator or an L2 that supports aggregation, and they'll bundle multiple different wallets as user operations together. In that demo, that's just the multi-actions within a user operation, and so that's a single transaction, a single user operation with multiple actions, and that's something like a UX benefit for dApps. So yeah, there's two different things there. One is the bundling of different user operations from different wallets to save transaction cost, and the other is the UX gain of multiple actions within a single user operation. But yeah, good distinction to point out. Yeah.
And still, the UI mixes too, because there is both the spender and the other one, and they're bundled together, even though they're supposed to be different signers, aren't they?
No, in that example, like the user flow without that would be you go to an exchange and you have to, approve the dApp, all of your X token, whatever it is, and then after you've approved the dApp that token, then you can do a swap, and then you trust the dApp to do your other actions, and you're signing those other transactions. So you're signing an approve all, a blanket approve all of your token, which is not a great practice, and then doing an interaction like moving a token, or if dApps want to be more secure but then worse UX would be before every interaction you need to approve that amount and then do that amount, say a swap or something. This was just to show that example that if that dApp does need to approve an amount and then move that amount, it can do it atomically as one. So either both will succeed where it approves n tokens and then moves n tokens. Yeah.
So question. So I think this rely on kind of EIP 4337 kind of smart wallet. Is any when a user want to use this, is any cost estimate how this wallet creation will charge compared to a normal wallet? For example, if I want to use BLS wallet.
Yeah. So this was started on this before, a little moment before 4337 was written about. But yes, our V2 will hope to make more in line with 4337. But the goal of the original project was about reducing transaction costs, so it was focused on L2 deployment only, not necessarily L1. Whereas I think 4337 is more about focusing on the more generic signing mechanism, whereas ours was to say specifically use BLS to save transaction costs on EVM rollups. But we may come to some middle ground where we can be 4337 compliant in the next version.
Thank you.
Does your wallet support the dApp sending 3 separate transactions, but the user choosing to batch them? It's like the user just doesn't sign individually; they just wait until all 3 have been clicked, then they sign.
I don't know if that's in our prototype, yes, but the client module does permit that. Yeah. So the idea is the client module will have all the functionality, and there can be local bundling. I guess you could do it either way. Like either you put 3 actions within one atomic user operation, or you could have 3 individual user operations that are sent. But sorry, no, I think your question was more so around can the user of their own interactions take 3 separate transactions and then choose to sign them as one action, as one user operation? Yes. Is that
correct?
Yeah. I don't think we've implemented that in the prototype yet. Yeah.
Like if I'm using a dApp and I'm going to go do 3 or 4 different things. For example, ENS, maybe I want to edit the owner, and at the same time I want to update an IPFS hash or something. There's no need for me to do those as 2 separate operations. I can just do them. There's no reason that I need to send them separately. I can send them as one. And there are some cases where you very kind of specifically want these 2 things to occur very close to each other. Not always, but it comes up, and so it'd be nice if as a user you can just say, hey, I'm going to do 3 things. I want to sign once at the end.
Yeah, in the Web3 World Discord, we created a separate channel for design, and we had a good review of a UX to say, look, might wallets want in the future, multi-chain, multi-action, blah, blah, blah. And one of the things was something like an outbox where you could potentially queue up a few. We haven't implemented everything in this design. It was more of a, what could wallets look like, and then the prototype is just more so to show the integration of the client. But an outbox concept was designed, but we haven't implemented that. At least I don't think we have. Jake, maybe you can correct me. I don't think we've gotten that far yet. We had it on the cards, and then we maybe pushed it back.
Yeah, there's also some information. Like usually when a DApp call into like a conference, it expects a response at some point, like for the transfer receipt up. There can be with like how the DApp's going to respond if you're all of those up and try those. So we have this a little bit, but with their the other thing that's important to note is that transaction we're getting actually through our aggregators. So it's actually looking at the bundle you use, and then it will actually return correct like a transaction hash that is in the example. It's just a bundle being submitted by Blake and. But in other cases, you need a L2 transaction, many bundles from many. And so there's no proxying we have to do to pass that through. So there's some more complications tracking all that stuff from a cart perspective with that as well. Check out.
Yeah, I'm not sure if anyone got that. Sorry, Jake. I think your microphone's quite patchy at the moment.
It's Fubar.
Hopefully people got some of that.
Unfortunately, we get half your words, and so if you speak densely, it's very hard to follow. If you repeat everything twice, then we might get it.
I'll rejoin, but yeah. There's some complications to stacking all that from what we've looked at.
Great. Yeah, thanks for the time. I don't know if there's any more questions, but we can carry on.
Awesome. Thanks a ton for putting that together, and that's really exciting to see it coming together. Now, when are we going to see this on mainnet?
Yeah, no, good question. We have the audit back, and I'm just going through the issues one by one. So, yeah, I don't want to give an estimate, but yeah. We'll be deploying to mainnet. Where are we now? August. Let's say after the merge. How's that?
Sounds good. No, that's awesome. I'm really excited about it. And I think Matt will be happy too when he gets his batch transaction endpoint. So, yeah.
Starting with Arbitrum, but yeah, that's where we are.
Cool. So if nobody else has anything they'd like to demo, then I guess we can go back to talking about the extension registry and other topics that aren't necessarily on the agenda.
What was the extension registry again?
That's the name of the thing that we're calling, like the URL scheme and all of those discussions are in the extension registry category.
A broad catch-all for wallet things, everything.
Well, specifically for how dApps communicate with extensions and other wallets. So, yeah. So where we leave off, we were talking about chaining wallets together.
Yeah, just some mechanism to make it so the people that are implementing signing tools don't have to also be the people who are implementing visualization tools and analytic tools and protection tools.
So my thought on that is it really seems like all of those. So if we imagine like a line between the application and the wallet, right? All of the chaining and connection stuff is on one side, the wallet side, whereas and the dApp needs to know nothing about it and doesn't care about it. So I really don't think the URL connection scheme needs to care at all about how the chaining is implemented, because that's completely different. Like, that's opaque to the dApp.
So, sure. So the dApp, when it connects to something, would maybe, let's say, connect with the wallet, the scheme, right? So wallet : / whatever. Here's how to get a hold of me. Opens up a server, whatever that means, and then something receives that and connects. You're saying that something then. I see what you're saying. I think the thing that keeps popping back up into my head is I feel like we shouldn't be leaking to any of these participants that the other participants exist even. So like, as an example, you can imagine there's some very popular wallet out there that currently does signing, and it also does some other things. It has some other features, right? Like maybe it offers user swaps right in the wallet. If some intermediate thing shows up in between the dApp and that wallet knows it, they may start taking action to, like, I don't know, make it so that things don't work as well or whatever, like to discourage users from using that other thing, because the other thing may be stealing their lunch, so to speak, by offering users a better swap in their tool. And this is kind of a pathological endgame, but I'm worried about going down that path where we are. Is the general privacy problem, right? Where if you leak information, someone will figure out a way to make money off the information leak. And that way of making money may not be in the best interest of the user. Whereas if we can keep that information hidden somehow, then people can't leverage it. Now, the reason I bring this up in response to your question is because it is not clear to me how we can avoid that sort of data leaking without having that decision be made somewhere in that initial interaction where the user is choosing their wallet. Like when that user gets that wallet prompt and they need to select their wallet, like whatever that means, I feel like that is the right time to make that choice and have the user, organize things or configure things or whatever. If that makes sense?
Yeah, it does. It's just I think a lot of this stuff has to be cooperative anyways, right? Like if I'm using, wallet A and I'm signing something and with a key that isn't in wallet A needs to know to forward that request. Like it all seems very cooperative. But
so wallet A... Go ahead.
To more specifically answer your question, why not just have like a router wallet that all it does is glue all the pieces together and then you handle all requests with that wallet?
Maybe that's the answer.
Can you provide a little more color on like what specific privacy issues you see with, okay, we're talking about a theoretical Fox swap feature in an imaginary wallet, and you're saying that potentially there could be something in between sort of their integrated application layer and then the core key management and signing. What are you envisioning?
So the general idea here is that when a user wants to interact with Ethereum, there's the dApp that they're interacting with, right? And then there is some tool that maybe offers them protection from scams. Like if you try to send a transaction to a known scammer address, it will pop up and say, hey, don't do this, this is a very bad idea. Maybe there's another tool that is, again, in that flow that does really good visualizations. And so when it sees you trying to do a transaction, it can display that or present it in a way that really makes sense to the user. And then there's the tool that does the actual signing, right? The idea here is that we don't necessarily want the people who are really good at key management to also be the ones that need to build a visualizer and need to build scam protection. Like those are three very different tasks, and we want to be able to delegate them to teams that are good at those individual tasks. And ideally products and have product competition that doesn't bundle them all together. So you shouldn't have to choose the wallet that does all three of those things good enough. You'd ideally choose three wallets, one that each does their respective thing very, very well. And so if we have this kind of these multiple tools in the chain between the dApp requests you to do something and you finally eventually sign it, and that last tool may be like a hardware wallet or something, I don't know. We need a way for them to communicate between each other. So you need to be able to pass the transaction first to the first one, like the scam checker, and then pass it to the visualizer, and then pass it to the signer. And ideally, you want to do that in a way that doesn't leak privacy of the user, like in a way that none of the pieces involved know exactly what the other pieces involved. So the scam detector doesn't know that you're using MetaMask or Rainbow Wallet or something else. Like they just know I'm detecting scams and I pass it along. And the visualizer doesn't know that you're using the scam detector. They don't know that you're using MetaMask, and because they just pass it along.
So I think one issue there, even if you're pushing for standards for modularity, that all wallets can, use these things, maybe something like almost like Snaps. The problem is, I think, more externalities in that, why do we see software wallets bundling in features? Well, it's differentiation, and it's a way to monetize wallet development. In particular, with MetaMask and swaps, that's basically, as far as I understand, like carrying consensus right now. And I had no idea it was going to resonate in that sort of way. So there's clearly a financial incentive for like wallets. And again, obviously I'm biased, but I look at like what Ledger does with Ledger Live. They almost want to be like a curated crypto experience, like AOL versus, direct access to the internet. And I get why that appeals to some end users, but I think you have to separate out technical standards and like what are the incentives for wallet teams to do all these things monolithically. So that makes it a tricky issue. I know it's not really constructive, but I see these as parallel and interrelated problems.
So I think that what you said makes sense, and it's a very valid point. I think that the incentives aren't there, and this is part of why I think that the privacy is important, because what I worry about is if wallets are incentivized to provide that one-stop shop, because that one-stop shop can include add-on services like upsells, right? Like this is exactly what MetaMask does, is they have a wallet and they upsell it. If users are able to get that upsell feature from somewhere else that's better, right? They're not going to use the upsell feature. And so this is why I'm concerned that if we leak the fact that users are doing this chaining to MetaMask, hypothetically, then MetaMask will, be forced to take actions to prevent that or stop that or whatever. And so whatever we come up with, I think if we want to maximize users' ability to have this choice of modularity, it needs to be done in a way that the individual tools can't know what other tools the user is using, and the individual tools can't prevent the user from using other tools. So like it needs to be designed such that the user or the wallet doesn't need to we don't need to get buy-in from the wallets. Like either the wallet works with we do need buy-in from the dApps, because the dApps will need to communicate in this new mechanism, but we wouldn't need buy-in from the wallets because the wallets need to work with the dApps, if that makes sense.
So I think if we're going to be talking about this from like wallets are the adversary, and I know it's kind of a weird position to take, but
we are the adversary.
If we're taking that position, then I think chaining is the wrong visualization or analog for it, because chaining is very permissive. Each wallet would be able to control which data is passed on to the next wallet. I think what you'd want to do is think about it from like an orchestrator or like a router point of view, where you have something that sits atop all of the routers and passes requests. Like first it passes the request to the scam detector, and then it receives a response from the scam detector, decides what to do, and then goes to the visualizer and gets the response and decides what to do. And so it goes back and forth to this orchestrator that sits on top of all of the wallets. That way there's no cooperation from the wallets required.
Yes, so I can definitely see an orchestrator potentially being the solution here. I'm going to contend a little bit that that's required. I think that so we know that the signer has to be at the end of the chain. I don't think it makes sense for the signer to not be at the end of the chain. Maybe there's an argument there where the signer is not actually at the end of the chain, but if we assume that the signer is at the end of the chain and everything else is not a signer,
well, the signer
has to pass it on.
So there are things that happen after signing, right? Like I remember there being like services that will send a transaction, like publish it at a certain time for you. So that will happen after signing.
I don't really understand. How can you separate visualization from signing? Because if the visualizer can decide what I see before I sign, how can you protect what the visualizer does?
What do you mean?
So like the visualizer is malicious and shows you the wrong transaction contents, let's say.
Oh, sure. So like the user does need to semi-trust each of these tools. They don't need to trust they need to trust the signing tool the most, because that's one that has their private keys. The other tools, they do need, like, if they're malicious, those other tools give them bad data. That is very possible, and there's nothing that prevents that.
Yeah, it's the whole Hugh Carp attack vector where, if you're relying on your tool to verify in a general computing environment, precisely what you're signing, there's that degree of trust involved no matter what.
Yeah, and I think having these modular components can help a lot with that, because a particular Paranoid user may actually install 3 different visualizers, and so they would verify that each visualizer shows them the same thing in their own UI or whatever, and so that way by the time it gets to the signer, if any one of their tools is compromised, then that's not a problem. Whereas if someone has to compromise all of their tools, and that's a much harder attack for an attacker. Like if you can take over MetaMask's update, for example, you can force an update on all the users, and now MetaMask is compromised on all those huge machines that just download the MetaMask update. But now you need to compromise MetaMask keys, and you need to compromise like 4 other visualizing tools keys. That's now all of a sudden much harder. And so I think from a security standpoint, having, allowing all these tools in there really helps you protect users significantly. Again, because they can verify over and over and over again. It's the same way ideally users are, when they're using MetaMask, you check MetaMask to see, does this transaction look right? And then you double check it again when it gets to your ledger. Now, of course, we know no one actually does that, but, at least in theory, that is possible.
One thing, and I know I'm just kind of throwing spaghetti at the wall here, but I liked something you said there where there could almost be something with this system that verifies the provenance of like the data source for each plugin like this, and actually, would advise you to rely on like multiple data sources to vet the signing request. I mean that adds like another layer to it, but provides better security guarantees.
Yeah, I think if we went with Sam's router thing, we could maybe achieve something like that, where the router could say, hey, we noticed you only have one visualization tool installed. We generally recommend you install, at least 2 from different sources. And here's some recommendations, just to kind of help encourage users to, follow better security practices. And that router tool wouldn't have to actually implement this visualization stuff at all. It would just have to tell users, hey, it's in a position where it can notice that the user doesn't have 2 visualizers in the chain. So that might be nice.
I think in either case, though, that's all on the wallet side of the dApp wallet divide, and I don't think that really affects how you launch the wallet or how you connect to it.
Yeah, I think if we do the router thing, I think you are largely correct. And I'm starting to come around just the more I think about it. I think having a single router that is your wallet from the point of view of the dApp, and when you get the pop-up, the router wallet is what's selected, I think is not unreasonable. And one can imagine a future where the browser functions as the router, right? So that's the piece that the browser actually builds and integrates, whereas the individual modules that the router uses is something that users can add and remove stuff from.
Yeah, I was just thinking that as you were saying it.
And we could call it an extension registry.
And we're back. Well done, Sam. Well done. Yeah, I'll chew on the router thing. I generally like the idea, and it allows us. I do like the scheme selector that Sam's been piping about, and so this would allow us to keep the scheme selector and not break anything, and it simplifies integration with dApps, because dApps don't need to worry about any sort of complex modularity system. They just sort of like, hey, I need a transaction to be signed and sent. Someone figure out how to do that, and that thing is that router. Yeah, I'll think on it more. I like it.
Cool. 5139, I forgot to mention in the agenda. If anybody's had a time to look at it, let me know. There's the implementation now with the TypeScript documentation. So yeah, I guess we have a working implementation of it for now.
1539 is a 404.
Sorry, 5130. 5139 is a 404?
You said 1539.
Oh,
I thought.
yeah, 5139. That's the RPC provider list proposal.
I leave for a day and there's external links.
External links?
Oh, just the JSON schema is a HTTP // JSON schema. I'm giving you a hard time.
Oh, yeah, that one is not optional, unfortunately.
Oh, and Semver. Don't forget that.
That's not external.
Oh, you clever dog. Well done. Okay, you win. You have
But
won
yeah,
this
so-
sparring round, Sam.
So on the Web3 Well repository, there or organization on GitHub, there is an implementation of this that can merge lists and do all the fanciness that is specified. I don't know how wallets do like libraries. Like, would you grab a common implementation for this for all wallets? Would you all implement it yourselves? So I'm curious about that.
Why does this list include the chain ID? I haven't read it all, so maybe this isn't the rationale. You can feel free to tell me to go there.
Oh, it includes the chain ID so that you can pick a set of providers for any particular chain ID and either query them all or query them in a list and make sure you're getting multiple
see.
providers for the same. Yeah. Cool. Well, if nobody else has any other comments, I guess that's it for today. Thanks for coming out.
Thanks again.
Thanks.
Cool, thanks. That was great.